Hello everyone. Today we are going to learn about some basic definitions in network analysis. So the first topic is network element. A network element is the basic building block of an electrical network. A network element can be defined as a mathematical model of an electrical device and is characterized by its voltage and current relationship. Also, a network element cannot be further divided into a device. Second topic is classification of network elements. Based on the behavior of network elements in the circuit, they are classified into following types. First one is the active elements. When a network element or circuit element has the ability to deliver electrical energy to produce power gain in the circuit, then the element is called an active element. Common examples of active elements are generators, batteries, other independent sources. Second one is the passive elements. A circuit element that can only absorb electrical power is called a passive element. We can simply say that the energy produced by the active element is absorbed by the passive element. Examples of passive elements are resistors, inductors, capacitors, transformers. Third one, bilateral elements. The elements for which the relationship between voltage and current remains the same for current flowing in either direction are known as bilateral elements. We can show like this. Wait a second. Here. If the current flowing in both directions, in that situation, if the relationship between voltage and current is same, then that element is called bilateral elements. If the relationship between voltage and current is not same, then it is called unilateral elements. The circuit elements that exhibit the different relationship between current and voltage for two directions of the current are called unilateral elements. Fifth one is linear elements. An electric circuit element that follows linearity property is called a linear element. First, we have to know that linearity property. Linearity property is a linear relationship between input and output is known as linearity property. The linearity property is the combination of two sub-properties, namely homogeneity property and superposition property. Homogeneity property is nothing but the input is scaled by a constant, then the output also gets scaled by the same constant. Example, E of t is the input and R of t is the output. E of t is scaled by the constant alpha, then R of t is also scaled by the constant alpha. Superposition principle. According to the superposition principle, the output corresponding to a sum of inputs is equal to the sum of outputs to each input applied separately. That is, E of t and R of t and E of 2 R of 2. E1 of t and E2 of t are the inputs, R1 of t plus R2 of t are the outputs. Sixth one, non-linear elements. The circuit elements that do not follow the linearity property, the relationship between input and output, are called non-linear elements. In simple words, the elements which are linear are called linear elements. The elements which are not linear are called non-linear elements. Seventh one, lumped elements. A circuit element is considered as a lumped element if its physical size is very small with respect to the wavelength of the signal. Therefore, the separate elements that are very small in size are called lumped elements. Examples of lumped elements are resistors, capacitors and inductors. Distributed elements. A distributed element is one that is distributed over the entire length of the circuit and is not electrically separable. One practical example of a distributed element is transmission lines. Okay, third topic is types of sources. We can classify the sources into two categories. One is independent sources, second one is dependent sources. So first one is independent sources. The One is independent voltage sources, another is independent current sources. An independent voltage source produces a constant voltage across its two terminals. This voltage is independent of the amount of current that is flowing through the two terminals of voltage source. Independent ideal voltage source and its VI characteristics are shown in the following figure. The VI characteristics of an independent ideal voltage source is a constant line, Y, which is always equal to the source voltage irrespective of the current value. Hence, the independent ideal voltage source do not exist practically because there will be some internal resistance. Independent practical voltage source and its VI characteristics are shown in the following figure. There is a deviation in the VI characteristics of an independent practical voltage source from the VI characteristics of an independent ideal voltage source. This is due to the voltage drop across the internal resistance Rs of an independent practical voltage source. Second, independent current sources. An independent current source produces a constant current. This current is independent of the voltage across its two terminals. Independent ideal source and its VI characteristics are shown in the following figure. Same like the independent voltage source, the independent ideal current source also has a constant line in its VI characteristics because it is irrespective of the voltage value and it has no internal value in ideal. In independent practical current source and its VI characteristics are shown in the following figure. There is a deviation in the VI characteristics of an independent practical current source from the VI characteristics of an independent ideal current source. This is due to the amount of current flows through the internal shunt resistor Rs of an independent practical current source. So, second one after independent sources is dependent sources. Dependent sources like voltage or current depends on the voltage across or current via some other element somewhere else in the circuit. Sources that exhibit this dependency are termed as dependent sources. Both voltage and current kinds of sources might be dependent and either be controlled by a voltage or current. In common, dependent source is symbolized by a diamond shape symbol as not to puzzle it with an independent source. The dependent sources can be categorized into following types. One is voltage controlled voltage source. In voltage controlled voltage source, the voltage source is dependent on any element of the circuit. Like in the above figure, the voltage across the source terminal VAB is dependent on the voltage across the terminal VCD. VAB is directly proportional to VCD or VAB equal to K is constant, into VCD. Second one, voltage controlled current source. We can also represent it as VCCS. In the voltage controlled current source, the current of the source IAB depends on the voltage across the terminal CD, VCD, as shown in the below figure. Here, IAB is directly proportional to VCD and IAB is equal to eta VCD, where eta is a constant known as transconductance and its unit is mho. Mho is nothing but opposite of ohm. Third one is current controlled voltage source. We can also represent it as CCVS. In the figure, current controlled voltage source of the network depends upon the current of the network as shown in the figure below. Here the voltage of source VAB depends on the current of the branch CD. VAB directly proportional to ICD, VAB equal to RICD, where R is a constant. Last one is current controlled current source. We can also represent it as CCCS. In the current controlled current source, the current source is dependent on the current of the branch another branch are shown in the following below. Here like IAB directly proportional to ICD, IAB equal to beta ICD, where beta is the constant. So for today's class, this is our topics we covered. We covered network element and classification of a network elements and types of sources.